Good morning, students. Today we are going to see the third part of the Unit 1 Electrostatics, in which the subunit is 1.4.1 Electric Dipole. We go to the PDF now. Okay. See the heading Electric Dipole. Di means two. Pole means two different charges. Okay. One is positive and one is negative. Okay. And what they do, how the electric field will be due to the similar charges plus q and minus q kept at a distance 2d, and their properties we are going to see. Now what is an electric dipole? Two equal, both are same magnitude but opposite charges. Opposite charges, one is plus q and one is minus q, separated by a small distance. For our convenience, we take the small distance as 2r or 2d, constitute an electric dipole. So this is the definition for electric dipole. In many molecules, the centers of positive and negative charge do not coincide. Coincide means they don't have the same center. So they are given in the different. So do not coincide. Such molecules behave as permanent dipoles. So what are called permanent dipole? They don't have the same center. Okay. Examples: carbon monoxide, okay, water, ammonia, hydrogen chloride, etc. Consider two equal. Here the explanation of the dipole. Consider two equal and opposite point charges, plus q and minus q. So always remember plus q and also minus q, that are separated by a distance 2a. The 2a means a is the distance from the center to the other two charges. Okay, as shown in the figure. This we are going to see now. Now the formula. Remember, in plus 2 we have to represent every formula with the vector form. Electric dipole moment is small p, not capital P. Capital P means pressure. Small p is electric dipole moment. It is not capital M. Remember carefully. Dipole moment is small p vector equal to q. This is the first charge. That is R plus, due to first charge, plus q charge, r cap, plus the another one is minus q, same r cap. Okay, minus, you have to remember. R plus my vector is a position vector plus q from the origin, and r dash is the position vector of minus q from the origin. Now we see the form, the diagram. So always in physics, first you should draw the diagram, then only you should explain. So if you know to draw this diagram, you can bring it. Now imagine the x and y axis. This is OX, okay? This is x dash, this is minus x axis, this is positive y axis. So remember, minus q on the left and plus q on the right. Remember carefully, minus q at a distance small a from the origin 0, 0. Here again the plus q is from 0, 0 a. So total distance from the center of the minus q to plus q is 2a and plus q. Okay. Now remember, always plus q to the minus q, the direction of the electric field. So remember, and both the sides, plus q to minus, not round. Remember carefully, from plus q to minus q, here plus q to minus q, and minus q towards the minus q, and plus q away from, you have to draw. You can check with the textbook. So electric dipole and electric field lines, this is called electric field lines for the electric dipole. Now in terms of distance and so what is the formula for electric dipole moment? Charge into distance. So q into a and the I cap along the x axis, minus q because of the minus q charge, a into, and in the negative direction minus I cap. So minus into minus plus. Okay, both are I. So both are having the same value, q plus q 2q and a I cap. Remember, this is the formula for the electric dipole moment, how to prove it. Now it is, we can give it in the statement form. Electric dipole moment vector lies along the line joining the two charges and is directed from, always remember, minus q to plus q, not from plus q to minus q. Remember, from negative charge to the positive charge. Then unit, how to find out? Formula is 2q into a. Q is the charge, so coulomb. A is the distance and meter. So the SI unit of dipole moment is coulomb meter. It is not centimeter, capital C, small m. The electric field lines for an electric dipole are shown in the diagram. For simplicity, to make you understand, they take the graphical representation. The two charges are placed on the x-axis. One is plus q on the plus ox axis, minus q on the minus x ox dash axis. That's a negative axis. Even if the two charges are placed on y and z axis imaginary, the dipole moment will be the same from minus q to plus q. So always remember, dipole moment, the direction of the dipole moment is from minus q to plus q. Then magnitude of the electric pole, this is a 2-mark question. Magnitude means what? Value. How to measure the electric dipole moment is equal to product of the magnitude of one of the charges, that is q, either plus q or minus q, and the distance between them, that is 2a, we have to multiply for doing the problem. Okay, then we go to the next part. So that is given in the formula. So P vector is electric dipole moment. We take it as modulus, okay, equal to 2qa. We are not writing I cap here. Though the electric dipole moment for two equal opposite charges defined, it is possible to define and calculate the electric dipole moment for a collection of point charges. Suppose there are so many number of charges are there, then electric dipole moment is a collection. Collection means sigma, you have to write I equal to 1 to n and qi ri. Remember carefully, Ri is nothing but 2a. Ri is the position vector of the charge qa from the origin. The problem and all we will do later. The example 1.10, when you open the school, that time we will do in the classroom. Now we go to the next part. 1.4.2, electric field due to a dipole. This separate 5-mark question. It is very important. Case 1, electric field due to an electric dipole at points on the axial lines. This separate 5-mark question. On the equatorial line, another 5-mark question. Remember, in physics, you have to study the full sentence. Okay, don't study only electric field. There are electric potential also there. Axial line and also equatorial line is there, or any point on in the space. So be careful with the sentence. So what is the question? Case 1, electric field capital E vector due to an electric dipole at points on the axial. What is axial line? Line joining the plus q and minus q and extend on both sides. They are called axial line. So first draw the diagram. Take a point A minus q, take a point B plus q, total distance is 2a, center is O, electric dipole from minus q to plus q, that is P vector, and we have the, take a point C where you keep the test charge q naught plus q. Okay, this plus q will repel, so E plus vector away, and plus 1 and plus q will, minus q will attract, so E minus will be this way. So you have to draw this diagram. So consider electric dipole placed on x-axis, this is x-axis. A point C is located at a distance r from the midpoint O of the dipole on the axial line. First you should draw the diagram, then write down this one. Okay, then we go to the next part of derivation. This is very, very important. You already memorize what is electric field formula. What is electric field formula? E vector k into q by r. Here r is nothing but r minus a whole square along BC. Total distance minus the smaller distance from OA, that is r minus a whole square. Similarly, for electric field, you have to use the electric P cap along the momentum, dipole momentum vector P vector from minus q to plus q. So P cap, remember this is P vector, whole vector. Here is a unit vector of electric dipole moment. Be careful, and you have to put E plus due to plus q charge. Similarly, for minus q to plus q, and we have the electric field for the negative r plus a whole square P cap. Okay, so and then we have the next part of the thing, which is stronger. Always remember E positive is stronger than E minus. So E minus vector is drawn larger than the E plus is drawn larger than E vector. So total is we have to add E total, E positive plus E minus is 1 by 4 pi epsilon naught q by r minus E whole square into P cap. Remember, it's not I cap, it is P cap, that is from minus q to plus q, the direction of the electric dipole moment. Similarly, same 1 by 4 pi epsilon naught, same q, instead of r minus A, you have to put r plus A whole square and P cap. Remember here plus and this will get minus into plus minus. What is common here? Only 1 by r minus A square, 1 by r plus A square is uncommon, all others are common. Take the common one and take out and take the thing, and they are given the formula and everything in the next part. Okay, so what are common? I told you this all common, take it out. So 1 minus r minus A whole square minus 1 minus r plus A whole square, you know already, this will come here, this will come here, A plus B whole square minus A minus B whole square equal to 4AB. How to remember? This r plus A whole square here, r minus A whole square here, these two multiply, A plus B into A minus B, A square minus B square, and here we have to put square only, not power 4. And this is nothing but A plus B whole square here A minus B whole square, when you subtract, no, A square and B square cancel. Similarly, here r square cancel, A square and A square cancel, 4RA is left. So remember, you can skip like that, but don't forget the P cap. Okay, always the unit vector should be on the other side. And see the diagram, again what you have written, the total electric field away from the C that you should draw. Okay, so if the C is very far away from the dipole or greater than AA, what is R? Distance from the center point to the C, O to C, the R is OC, and this is OE and OB, A. Then under this limit, we can remove this A square, we take only R square whole square, R power 4. So I can't understand, sir. Imagine R is 100, this is 1. So 100 square is 10,000, 1 square is 1. 10,000 minus 1 will be 9,999, which is nothing but we can write R power 4. Okay, so we can neglect A square, not A square. So we take R power 4. So in the denominator we write R power 4. Already one R is there, cancel, we get R cube. They skip the point. Okay, here R will be there, R power 4, cancel R cube. Okay, then you should remember what is P vector. P vector is what? Memorize 2AQ P cap. So 2AQ P cap, the 2 is remaining, that they write, then P vector. This is the final answer. Okay, when R greater than A, don't combine with this we can write separately. This is only the box for doing the problem. If the point C is chosen on the left side of the dipole, the total electric field is still in the direction P vector. We infer this result by examining the electric field lines of the dipole. Now, up to this one, 5 mark question over. You are finding for the axial line. Now you are going to see the equatorial line. You can underline this. Be careful. Always read the full sentence. You will confuse with the electric field with the electric potential also. You will confuse with the axial line to equatorial line. So be careful. See with the question. What is equatorial line? This is axial line, and perpendicular to axial line is called equatorial line. So consider a point C at a distance R from the midpoint center to this side. Now, okay, upper side of the dipole on the equatorial plane. This is called equatorial plane. This is horizontal. This is axial plane. This is the equatorial plane. Okay, since the point C is equidistant from plus Q and minus Q, the magnitude of the electric field C will be plus Q and Q are the same. They won't change. The direction will be only the away. See the diagram, how they do. There are 2 diagrams to make you to understand. So this is the plane angle and this is 90 degree, and okay, and one will be, I told you how to draw this one. You can put plus Q, plus 1 and minus Q will attract, so E minus will attract, and plus 1 and this plus Q will repel, so it goes like this. The resultant will be this side. So total, that is only they have given here in terms of cos theta. This angle is theta, this angle is theta, this angle is theta. So this is theta, this is theta. I told already in 11th standard where it contains the theta, that is cos theta. So E plus cos theta, this is E minus cos theta, but this should be perpendicular, E sin theta, here E minus sin theta. That you should remember. So that you draw, first you should draw this line, the diagram, then explain. Okay, now we go to the next part. of E minus vector is along BC and the direction E vector minus is along CA, then both can be resolved into two components. One is horizontal along the theta, that is here vertical sin theta, or equal magnitude to opposite direction. They cancel each other from the upward and downward direction, and only the total will be sum of the parallel components. Parallel means cos theta. E vector is direction is along P. So E cos theta and P cap. Remember, the P cap is the unit vector along the electric dipole moment from minus q to plus q. So both are minus. So just to take the same, and 1 by 4 pi epsilon naught, the value q by r square plus ia square, that you get it. How you got this answer? This hypotenuse is equal to r square and a square. So that is given here. Okay, q by r square plus a square. Actually root will get, squaring that you get r square plus a square. So cos theta, better you get the value, you get the answer. Okay, then again you write this one, substituting the value 2q cos theta r square plus ia square p vector, and here cos theta value substitute 1 by r square plus a square theta. Square root. So power 1 plus half will be 1 and half. So 3 by 2. So cos theta from the diagram, a by root of r square plus a square. Okay, then we go to the next part. So E total will be, combine this. Okay, here r square a square, the a square is neglected, and p vector 2qa into p, as you done in axial, we get the final answer p cube by r cube. Okay, not over. So now inferences from the equation 1 and 2, inform that first one is axial is twice the underline, this one twice the equatorial line. So 2 instead of 2p, we get here p only for the equatorial plane. Okay, so twice, 2 times. The direction of the electric field points at the dipole axis directed along the direction dipole moment, but all points equatorial plane opposite dipole moment at is minus p vector. Seeing that diagram, you can write at very large distance the electric dipole varies from 1 by r cube, from the formula. Okay, note that for a point charge the electric field varies as 1 by r square. This implies that the electric field due to a dipole at very large distance goes to 0 faster than the electric field at a point charge. So this 0 make it as 1 mark. The reason for this behavior is at a very large distance the two charges appear to close to each other. They neutralize each other. So I can't understand, sir, minus q here plus q here. When you go to higher level, from there it appears to both are nearer. So they cancel each other. Okay, the equation valid only for large distance. Suppose the distance 2a approaches 0. What is 2a? Between minus q and plus q. Q approaches infinity. Automatically charge will be infinity, such that the product will be 2a into q will be p is finite. Then the dipole is called a point dipole. So what do you mean by point dipole? When 2a equal to 0, distance between minus q and plus q is 0, then it is called point dipole. What do you mean by that? They coincide. For such a point dipoles, equations are exact and wholly true for any r. Okay, next one is, this is another 5 mark question. Torque. For torque means what? Rotating the couple. Okay, moment of the couple is called torque. When you apply one charge on one side, the other charge on the opposite side, but the equal magnitude, start rotating either clockwise or anti-clockwise. So the electric dipole is experiencing some torque when it is kept in the uniform electric field. Already electric dipole is already, it has positive and negative charge. But you in the uniform electric field, from minus q to plus q, the tail to head. So when you are keeping the dipole, it will align one making an angle theta, that you are going to find out. So consider electric dipole of dipole moment p vector placed in uniform electric field E, whose field lines are equally spaced and point in the same direction. The charge q will experience so now from the formula we get E equal to F by Q. Here you can write F equal to QE. Remember how you got? E vector equal to F by Q. So F equal to what? Cross multiply QE in the direction of the field. If the charge is minus Q, the same formula, minus Q into E in a direction opposite to the field, and they are uniform, the total force will be 0. These two forces acting at different points, because two other points will constitute a couple and will make a rotation. It is a dipole experience torque. Torque means what? Rotation here. To rotate the dipole, the electric field lines of uniform field equally spaced. Like how to? They draw the parallel lines. They are equal. at the same direction. Total torque on the dipole about the moment O is given by the formula. Memorize this formula, tau equal to F into distance. F is OA vector plus minus Q into E vector plus F equal to OB vector into QE vector. Make it equal with the tau, and we have the sin theta, we have the sin theta. So this is Q and QE, and this distance 2A. So QE 2A sin theta, we get the answer. And here P what is? 2AQ. So P E sin theta. In the reverse order, we can write here P E sin theta equal nothing but P cross E vector. A cross B equal to AB sin theta. Reverse order, AB sin theta equal to A cross B. Like that, P E sin theta equal to P cross E vector. This is the vector form of the torque. So value is P, A cross B equal to AB sin theta. So P E sin theta, small p, don't put capital P. And maximum when theta equal to 0, sin 0, 0, sin 91. So when theta equal to 90, this torque tends to rotate the dipole, align it with the electric field E. Once P is aligned with E, the total torque on the dipole becomes 0. If the electric field is not uniform, if they are not uniform, they are not parallel, they make curve linear, then the force experienced by plus Q is different from the experienced by minus Q. In addition to the torque, there will be a net force. Very important one more question. Okay, net force means total force acting on the dipole as shown in the diagram. See the diagram. This is non-uniform electric field because they are not parallel to each other. One will be rotating one day and other will be like that. Not they are parallel. So net torque will be there, and also net force will be there. Okay, example 1.1 we do it later, but even though it is very small question, you just substitute the value P E sin 90 equal to, substitute the value, you get Newton into meter. This is asked in 2 mark question. Okay, here we can go to the next part, 1.5, electrostatic potential and electropotential energy, okay, in the next class.